Hi, everybody. Welcome after the break. We'll start today with with a platformer game, right? So we'll start building a platformer, and we'll start looking into physics more than in previous game. So let's create a new project. Give me a second. I will log in. Okay, let's create a new project. Platformer. This is 2D game. Stay with 2D for this part of the course. I'm not adding new asset packages, just creating the project. Wait for the Unity to start. Okay, and before we start, I want to download few things from Asset Store. Instead of creating my own assets, I will use a Jungle 2D side scroller pack. That's the one. To the Jungle side-scrolling platformer pack. That's one package that I want to download. I will use platforms from there and maybe a few other elements that we'll use in the game. And the other one will be Maya Indian, and that's the set of images that will be used in the animation of the main character. Okay. Again, we'll have to wait a few minutes till it downloads the packages. What we'll do today, building this game, we'll start creating the scene. Right now, just one platform, saving it as a prefab, adding all the elements that the platform needs to have. We'll create our character, and we'll start using physics engine to move the character. So moving left and right and jumping. That will be our goal for today in terms of movement. We'll also start using animations. So we'll add basic animations for walking, running, and jumping. And we'll add also a kill zone, so we just don't fall into infinity in the game, right? A few interactions that we are going to create today. Okay, so Maya Indian. This is our hero. There is also a paid package with this guy that has more elements. This one will be enough for us, at least for today. The only thing that I see missing in this package is the idle animation. So we'll pick something to create this idle animation.
What's the title of that package?
Maya Indian Hero. Okay, it's time to start. Let's create folders for our prefabs. And let's create folder for our scripts. Let's save the scene. And we are ready to add our first thing. So in the first package, we have day, night, and sunset. There are different polar versions of elements that we have. Let's build the first platform. Right, we'll need a middle piece for 2, one end, and the other end. I'm adding all of them to the hierarchy because it makes them all on the same level. So it's easier to work with this thing later on. And 1. And the end is here. Right, so that's my platform. Hope you like it. What I don't like is that I have 4 elements that are hanging in the hierarchy as independent elements. What I want to do, I want to create an empty object, call it platform, make all those pieces into one piece. Right, this way, the whole platform can be edited or moved together. Another thing that is missing, is I said we will be using physics, we need to have a collider around the platform. Right, so we have to add component, physics 2D. We can use either box collider or edge collider, depending on how we want our platform to behave. And I will use box collider because I want my platform to be quite solid from both sides, top and bottom. I will also make this top edge of the platform a little bit below the grass, right? So your character will sink into the grass. It will look nicer this way. Okay, so having that, we can save our platform as a prefab, right? Dragging it into the prefabs folder. We'll be able to add more platforms later on. Oh, my scroll doesn't work.
Is there a reason why I didn't change the pixels?
Yes, I don't want to change it because all my elements have the same pixels per unit ratio. I would have to edit all of them, just too much time to do that. Make our camera bigger. And if we do that, then we don't have to worry about the ratio. Okay, so that's our platform, right? And right now with the prefab, if I want to add more, I can add another one, right? And it's configured. Okay. I told you, and by the way, if you want to build different levels, right, with this pack, you can easily do that, right? You have different colors. It's easy to at least visually distinguish the levels. Okay, I told you that in our pack, the hero pack, we don't have idle animation. What I will do, I will create a folder idle. And then I will take some, which one was it? I think it was attack. I will get first 3 frames from the attack animation, and I will use them as my idle. It's not the best, won't be the best animation ever, but it will give us something to work with, right? So right now, if I go to idle, I have these three elements. I think you remember from our last meeting before the strike, we did the animation of the explosion, right? And the easiest way to create animation in Unity is to select all the images that you want to have in the animation, just drag them to the scene. Right? That is idle. We have our player. Here it is. Automatically, controller is created. The first clip is created. Controller is also added to the animator of the player. I will change the name. This name is not very user-friendly. Hero 007 attack anim 001. Right? Player will be my new name for this guy. I hit the play button right now. We have very windy weather there, and he's hanging in the air, right? He's hanging there because he has no rigid body, right? So the gravity does not affect this guy. Let's add the rigid body to him. Right now, if we play, he will start falling and go through the platform. And that's because we don't have any collider, right? So that's another thing that we have to add. Sorry, physics 2D. And we can use all kinds of colliders. He is quite bulky, so you can use either polygon collider or capsule collider that will go around this guy. And I think capsule collider will work pretty well in here. So we want it a little bit smaller. We won't care much about his extremities in terms of collisions. And right now, we hit the play button. We can walk, well, stand. Right now, we can stand on the platform, right? Okay. It's a good time to make this guy moving. All right. Let's create a script. Player controller. The script will be attached to the player. Make sure that we are using mono. Preferences, external tools, mono develop.
You didn't change the pixel ratio, right?
No.
Why?
Because I would have to edit pixel per ratio for all my elements. So I'm using it as they are. They're more or less in the same scale. So it works well, right? If I change it for one of them, I would have to change it for everything. Okay, let's edit our script. Here we are. I don't think you can read it. So let's probably better. A little bit. Okay, we'll be using force, right? And we want to have some control over how strongly we are pushing this guy. So we'll use a serialized field, private float, and that will be force multiplier. For now, it will be 1. We want to be able to change it, right? Also, we'll be using rigid body and the animator in our script. And to avoid, calling for it every time, we'll create variables that will remember them. Private rigid body to be. All right now, private animator. Set both rigid body and animator in the start function. Okay, so animator equals game object get component animator and rigid body, basically same thing. Game object get component rigid body 2D. Okay. With that, we are good to go. Not exactly. If you go back in your memory to one of the first lectures when we've been introducing the idea of the physics in Unity, we said that there are 2 functions that you can use to make updates. One is update, it's called 1 per frame. The other one is fixed update. And fixed update is synchronized with the clock. Physics is also synchronized with the clock. And that's why in here, in this game, we'll be using fixed update more often than update. Right? Every time we work with the object that is subject to physics, we'll switch to fixed update instead of update function. Okay. We'll get input from the user. We'll create a vector 2 that we'll call force vector. And this vector will hold the information about the input from the user. Right now, we want to focus purely on the horizontal aspect of the movement. So we'll get input, get axis. Hope you remember this function, mostly because it will definitely appear on the midterm next week. So input get axis, and the parameter here is the name of the axis, and we want to have the horizontal axis, right? I'm leaving the other one as 0 because I want to ignore the y aspect of the movement. Yes?
Yeah, horizontal there.
Horizontal. Sounds nice. Thank you. Okay, if we have that, we can use the rigid body. We can add force, meaning push the guy. The force vector multiply by our force multiplier. That's it. That should allow us to move the guy left and right. Save, build. Play. It's moving. Okay, what happened? We have our collider round on the bottom, right? So when I'm pushing the guy, he's rolling. I could use the square, I mean the box collider, but it's not really a solution. Because if you're using if you're using the box collider and there is a tiny obstacle, it will trip anyways, right? What you have to do, you have to go to the rigid body, and in rigid body you have constraints. You can either freeze the position on one of the or the other axis, or you can freeze rotation. You want to freeze rotation in our case. Sorry, where freeze position would be useful is in a situation when you want your player to move only along one axis, in one direction. So imagine the game when you have a falling fruit or whatever, right? And you have this bucket that is catching those things, right? You want to fix your player to the movement on left and right, right? Then you can freeze position on Y and achieve this effect, right? With the frozen position, it's really hard to move this guy. There is friction. What I can do, I can change the mass, decrease the mass, or I can increase my multiplier. I did set it to 10. And here I am moving with the force. I can also be falling. One thing that you probably don't like is that if I'm pressing the left arrow, I'm going forward, but if I'm pressing the right arrow, the guy is going backwards, right? We want to flip. And if I'm moving forward or backwards. In the platformer, the character should flip and face the direction that he's moving. How we can do that?
Animation can make a limiter.
You could use animation, but that's kind of overshooting.
Event, whenever we press, for example, Y key, kind of flip, and vice versa.
Let me show you something. I can use scale. Very simple trick. But what's important, now if I play my animation, because the whole thing, the whole character is flipped, the animation will be also flipped. So I won't have to create animation, like different animation, walking left or right. I can use one animation to do that and use the scale for flipping, right? So that's what I'm gonna do right now. I will jump here, and I will check if my velocity, rigid body dot velocity, is is less than 0. Less than 0. Sorry, more than 0. It's more than 0. Then I want to set the local scale of my player. So game object dot transform dot local scale to be as follows: new vector 3 minus 1, 1, 1. Else, going back to 1. So that's the switch that I did in the editor before. Let's see if it works. What did I? Oh, velocity.x. Of course. Sorry for that. If I didn't mess up the directions, the signs, it should work. Right? Flipping. The only thing right now is that when I stop, it automatically flips to the left. If you don't like this behavior, what you can do the following. Get this if statement and turn the else into else if and say change the direction only if the velocity changes, right? Right now, if I walk to the right and I stop, I'll be still facing right. Okay, what's next? Jumping will be next. So we want to make our hero jump. And to do that, we'll need more variables, a little bit more code. Serialize field, float, jump, multiplier, let's say 30. Why different multiplier? Well, because we wanted to jump, right? Not just barely, not nice. Let's save. Let's save. Let's make sure that we have all this. We want to have a more force, right? More energy when we are jumping. That's why I divide this, right? I distinguish force multiplier from jump multiplier. It should be maybe movement multiplier versus jump multiplier. Okay, so that's one thing. Now, let's go to our fixed update. We'll add some comments. Walking. This is flip. And here will be our jump. Again, I will use get access to read the input from the user, right? I'll have a variable jump. I will use input dot get access jump. Believe it or not, but there is access called jump defined, and it is associated with space. Let me show you that. If you go to edit, project settings and input, you'll have the list of all kinds of access that you can use. And there is jump, and the positive button is space. There is no negative button, jumping kind of into the ground, that would be. You can still do it, right? It can be crawling. That's what we are using. You can also use the vertical one if you want, right? But it's in the platformer, it is good to save the vertical axis for climbing and actions like that. Right? That's why we are using jump. Okay, so we have jump. If jump is more than 0, so it means that the user is pressing the space bar. What we want to do, we want to add force to the rigid body. Add force. The force is straight up. So we use vector2 up, and we multiply that by jump multiplier. Seems correct. Let's build it. And let's test it. What you should have at that point the flying Indian. Because if you keep pressing the space bar, you can fly higher and higher. And with arrows, you can control the direction of your flight. Okay. That's not necessarily what you want to have, right? In most platformers, you cannot jump from a thin air, right? In most platformers, you have to be grounded to be able to jump, or you have to be grounded to be able to change direction to run. So let's think how we can detect if we are grounded. Any ideas? What I will need a function that will tell me I'm grounded. Usually parents do that, but in this case, we need a function. Well, you could use it. You could use the physics engine, right, and the collisions to tell you that. That's again a little bit too much in terms of computation. What we'll do, we'll draw a line sticking downwards from our player. If this line is crossing anything, any collider box, means that we're grounded. There is nothing below, means that we are in the air. And again, if you recall our discussions right before the break, I've been talking about raycasting. Raycasting is exactly that, right? There is a function in physics 2D. There is a function called line cast that is allowing us to do it in 2D. One thing that I will need in my function is the size, the boundaries of my image, right, of my sprite. So I will need a sprite renderer because this object can give me the size of the sprite. Game object dot get component sprite renderer. Line casting returns an object of type raycast hit 2D. A result. Now, physics 2D, line cast. Line cast takes two parameters, two vectors, position of the end and the beginning of the line. We'll need also, just to make the code a little bit shorter, more concise, we'll need a position. So vector2, we'll need position of our player, right? So game object dot transform dot position. Now, the beginning of the line will be position.x. That's the center in terms of x. That's the center of our sprite. But we want this line to be sticking out from the bottom. We don't want this line to be crossing our character, because that will be automatically the first element that is returned, right? So we'll take position dot y minus bound size dot y divided by 2. That's the starting point. Finish point is very, very, very similar. But we want to add just a tiny bit on the bottom. Okay. And if that is crossing anything, then it means that we have a hit, right? That we are standing on something. So return press not null and press dot collider not null. We have the result, and the result has a collider box, means that we are standing on something. One thing that we can do just for us for debugging, we may want to see where is this line. And the debug function, sorry, the debug class has a function draw line. This function exactly takes the same parameters as the line cast, and it allows us to draw the line that we are using for line casting. Hey, where do we call this function? Well, definitely here, right? We want to check if jump, so if we are pressing the space bar and we are grounded. That's the only situation when we will allow our hero to move up. You can, do similar thing for moving if you want. Right? You can add if statement before this one and say you can only move right or left if you're grounded. Okay. Let's see. I will show you the game and a scene together, because this way you will see the line. I don't know if you can see it. This tiny little bit that is blinking there, right, when I press the space bar. And you can see it here, the white dot. That's our line that is trying to detect where we are. We can also see that the bounds of this sprite are bigger than the bounds of that we would like to have, right? We can change that. Sorry, not here, but we could edit this, right, and make sure that this guy is kind of closer, right? That the bounds are closer. You can actually edit. You can edit your images here, right? Making this closer would make a big difference later on. Apply. But I would have to edit this for all of them and then recreate my animation, right? Not the best, not the best package for animations. Okay. So we can run, we can jump, we can fall. Let's make sure that we are not falling into infinity. We want to have a situation as follows. We have the kill zone on the bottom. It's long enough to stretch to the whole scene, the whole level. If we touch this kill zone, right now, we'll just respawn the player into the starting point. Right, so we're getting back to the beginning of the level. Later on, when you're building more advanced gameplay, you can add a life system or some other things, or health system or whatever. Right now, what I will do, I will add empty object. I will call it a kill zone. I will make sure that somewhere on the bottom, and I will add a collider. That will be edge collider. And I will make this collider long enough for my level. Right? It's stretching right and left. I will also add a script I'll do it. Kill zone. I will add this script to my object. I'll make sure that everything is saved in case. And I will edit this script. Script will be very simple. We don't need start and we don't need update. What we'll need to know where to teleport the guy, right? So serialize field, transform on point. Had no need for start and update, but we'll use public void on collision enter 2D, right? Collision 2D, other. And what we have to do, we have to take the guy that is colliding with us and teleport him into spawn position, spawn point position. That's it. One more thing that you can do here, you can make sure that the player that is teleported to the beginning of the level doesn't carry the velocity that he had when he got killed. Right? Imagine that you're falling kind of sideways or sliding, you get killed, then you reappear on the first platform, and you still have this velocity. So you just fly and get killed again. That's something that you don't want to have, the effect that you don't want to have. So what you can do, you can get the rigid body of the player. Rigid body equals other game object get component. If it has a rigid body, and we say rb dot velocity equals vector 2, 0. I cancel the velocity that the player has. Let's test. Here we are. Here we are falling. And we are standing on it. Why? Because we didn't assign the spawn point. Game object create empty spawn point. Spawn point should be above the platform. And then it should be assigned to the kill zone. Now it should work. Falling, jumping, and here we are again. Okay, one more thing. Quite annoying that the camera is not following the player, right? Is it? Let's create a script that will change that. Camera follow. Basically, with this concept, we'll add this script to the main camera. Basically, with this concept, you can make any object to follow any other object. Right, we have a target. And in update, what we'll do we'll take the game object, transform position, and we'll set it to be equal to new vector 3 target position dot x, target position dot y, game object transform position dot z. Now question, why in this vector I'm using target position x, target position y, but for z I'm using game object transform position? Sorry?
That won't change.
The z won't change, that's true, that's the result of this assignment, but why? Why not just game object transform position equals target position? Why do we want z to be different?
Position's frozen on that option. This position's frozen on that option.
Not really. We could move camera on z. But what would happen if I set the camera to be exactly where the target is?
But you zoomed up right on.
We'll be inside the target,
Yeah.
basically showing what's behind it.
Yeah.
Right? What we have to do, we have to be on top of the target, right? Hovering on over the target. And that's what we are doing right now. Okay, we have this. We can switch back to Unity because we have to assign the target, right? So we have to select the main camera. And for the target, we have to select the player. And right now, if we move, or if we fall, the camera is always following us. And now we'll be playing a little bit with animations. We'll create animation for walking, or running in this case. That's the animation that we have. And we'll create animation for jumping. And we'll create connection between the scripts and between the animator so we can switch between animations. Okay? Right now what we have, if you look into the hero folder, right, we have animation that is playing idle. Here it is. Right, what we have to add more animations. Again, we can we can do it simply through going to the folder, selecting all elements, and we can drag them to the scene. Hello. For whatever reason, my mouse is not responding in a way that it should. Okay, finally. Run. I don't need this guy in the scene, and I don't need the controller. What I need only the animation. I have the script, not really the script, the clip created. I can go into Animator, right-click in the gray space, and then go to Create State from selected clip. We'll add new state that is attached to the clip that I created a minute ago. Right? Another way to do it is create empty state, and then you have to select the clip that you want to attach. Right? Either way, what you need to have the state created and attached clip to this state. Now we can make a transition from idle to run and from run to idle. And if we leave it like that, what we'll have our guy running, stopping, running, stopping, because here, right, you're making transitions between these two states. Not exactly the behavior that we want, right? So what we want to do, we want to add parameters to this animation, to this animator, right? Going to the parameters tab, plus integer. We'll make decision based on velocity. if we have velocity that is not zero, not equal to zero, we are going to run. Why I'm selecting not equal instead of greater than? Because velocity can be positive or negative depending on my direction, right? If the velocity is equal zero, I want to go back to idle. In both cases, I don't need the exit time. Has exit time means that you're waiting till the animation stops playing before making the transition. I don't want that. I want to make the transition immediately, right? In both cases. Okay, if I did that, I can go back to my script, to the player controller, and I can use my animator. Animator set int velocity. What will be the value? Value will be rigid body dot velocity dot x. But this is float. Why I'm not using float? Let me show you that. I'm not using float because when it comes to the comparison with float, the only two operations that I can do is greater or less than. That's why I don't like float as a parameter here. That's why I'm using integer. Okay. Let's delete this one. Let's go back to the scripting. So I have to cast my velocity to the int value. And what I really want to do, I want to take only the absolute value. I don't care about the sign. Right, so I will do the following. Math f dot abs save. Now we can, and I will move this to the bottom so we can observe what happens. I'm in idle. Now the velocity changes. I'm running. There is a slight delay. I don't know if you can see that before I switch the animation, and it's because of the rounding. If you want to minimize this, you can multiply this value something bigger. It will minimize this delay. I missed the kill zone. You notice also that we are playing the run animation also when we are not grounded. And that's not really looking good. So let's create let's create a jump animation the same way we created run animation. Jump. let's go to the animator. Maybe I will show you how you can do it with empty. I create empty state. Jump is the name of the state. And I need to assign the motion. Motion is the clip, the animation that you want to play there. For jump, I will add new variable, new parameter, and it will be Boolean. I will go to jump either from idle or from run whenever jump is true. And again, I don't want to have exit time. I will go back to run if the jump is false and velocity is greater than 0. Right? And I will go to idle only if velocity is equal to 0. The velocity is equal to 0 and jump is false. If I have that, I can go back here. And really for me, what does it mean that I'm jumping? Does it mean that I hold the space? Not really. It means that I'm in the air, right? So my jump in our code translates to is grounded. Right? So I can say animator dot set bool jump is grounded. Right? If I'm not grounded, it means that I'm jumping, right? So not is grounded. Let's see. It's working. Any questions? Okay, I'll make sure that everything is saved. I will stop the recording now, and we'll have a few minutes to talk about the midterm and assignment dates and all that.